So what is Turing machine? And this Turing machine is an accepting device which accepts the language recursively enumerable set generated by type 0 grammar, and it was invented in 1936 by Alan Turing. Okay, don't get if you did not understand the sentence definition of this, no problem, I will explain you in detail while taking the example of previous like finite state machine, what is a finite state machine and what is push down automata. Okay, then I will come to Turing machine. Okay, so here this is a hierarchy of language. First, regular language is finite state machine is a regular expression with the help of finite state machine. And here context free language, context free grammar, that is push down automata. Then after that is Turing machine. The first one is finite state automata, it for the deterministic, and context free language is for like non-deterministic things, and Turing machine is more powerful than these two. Okay, finite state machine and push down automata. To overcome the finite state machine is introduce the push down automata to overcome of some of the problems for the big computational. So is invented the Turing machine in 1936 by Alan Turing. Okay, so I will show you this diagram. Okay, so here the first one is, this is finite state machine. Okay, we can say this regular expression, we can say this is finite wait, let me change some of the settings. So here I am changing the size of is small. So here this is F finite state machine. Finite state machine is regular language. And what is context free grammar? This is PDA, this two. Okay, this is also a PDA. When we scroll down, recursively enumerable, this is called Turing machine. Turing machine. This is Turing machine. So for you, little bit I will do small. The small one is FS, I will make it here. First one is FSM, finite state machine. Okay, finite state machine. In this we will take the input string. What we will take? Input string. So what is the input string? In the form of like this. Any string we will take and we will solve. Okay, like here one more I will add. So here 1 0 1 1 0 1, or last one also 0. Okay, so this is a string 1 0 1 1 0 0. So, based on this kind of problems, we use the finite state machine. If we have a simple string in the form of array, okay, we will use the finite state machine. So, that is a regular language. Second one is PDA. What is PDA? Push down automata. Push down automata. Okay, fine. So, here in the push down automata, it will take the input string, but it use the stack. What it will do? It use the stack. So, it use stack. Okay. So, if you see the previous video, then you can easily understand what is push down automata. So, here this is string example 1, 2, 3, 4, 5. So, here I will take the same string 1, 0, 1, 1, 0, 0, anything you can take. So, this is my string. So, here this will be the PDA, this will be PDA, and what is this? All 1 0 1 1 0, this is terminals, okay, and it will store in the stack. It will store in the stack. So, what is this? STACK, stack. And what is this? Rest. Like to identify why we are taking rest means to identify the empty string, means empty stack. So, we need to take the rest, okay, and it will send the data to stack and it will get the data from the stack. So, this is the simple structure, simple design for push down automata. What is the difference between here and there? In the first one and second one, this is used for the finite state machine. Okay, I will write this. State machine. Okay, here at this corner, because of the image you cannot see this, so I just move here. So, what is the first one? Finite state machine is the input string, it will take the input and it will use array and it will solve the automata problem. And here in the PDA, push down automata, it will use the stack, and with the help of this we can solve the problem, whatever we have the problem. Now, the third one is Turing machine. Turing machine. So, here in this, the important thing is it use the tape. It use the tape. So, the tape is nothing but like it will be like this 1 2 3 4 4 5 so on, no, and here you can use any symbol, like if I use the B, then it will be a problem. So, I will use this symbol for the blank, okay, and here all the terminals like A, B, 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 A, okay. So, here we will get the string and here the blank. So, what is this string? Tells how we can define this. This we can write A, B, B star and A. A followed by B star means number of B's, and B followed a single A. This is language. Okay, fine. So here like this, if we get the problem, we need to define like A, B, 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 any number of B's and single A at the end. Okay, A followed by B, B followed by A. So this is the equation, like whatever the string we have written here. How did I write this? Means if in the exam if you get like A, B star A, then you can write in this format A, B, 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 any number of B's, but that should be first A and this B should be followed by A only. If any extra A is there, this will not satisfy, this language will not satisfy. Okay, and this is not a context free language. So now it is context free language. Okay, so here A, B, 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 A means this is all the terminals, and here in this the important thing is it will be anywhere head. In the tape, in this tape, okay, TAPE tape, we will have the terminals and we will have the head, anyone, anywhere will be there. Okay, so there will be some condition that I will show you where should be the head. Based on that we will see. Okay, and what is this symbol? This symbol is for blank, blank symbol. Okay, and what is this dot 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 dot? This is infinite. Okay, this will be infinite. So here this is not part of terminals, but it is also not a like empty, it is a blank, the special symbol we can say. Okay, and here, so here the alphabets. Okay, first one, tape alphabets. I hope you remember this alphabet. Alphabets sigma is equals to flower bracket. You can take any, like any number, terminal, not terminal. Okay, like A, comma B, comma 0, comma 1, X, anything. Okay, that will be Z, Z0 also will be there. Then I will show you what are the things, what are the tuples the Turing machine has. Okay, that also I will show you tuples. Before going to the tuples, just I want to show you the small introduction related to this to understand you in the further classes. Okay, so here A, B, 0, 1, Y, Z, this all the things are input string, input symbol. Okay, input symbol. What we, as you know, the sigma is a input symbol. Okay, so the next, the blank. Okay, what is blank? Blank, it represent as like this, is a special symbol. Is a spatial symbol. and you must remember this does not belongs to sigma. Okay, you cannot add here. So blank symbol does not belongs to sigma. Okay, remember this. And next, the blank is a special symbol used to fill the infinite tape. So why we are using the blank symbol? Blank symbol, okay, blank symbol we are using used for infinite symbol. Okay, blank symbol is used for infinite symbol, infinite tape, sorry, tape, infinite tape. Okay, this is very, very important. Blank symbol, you must know about this. So once again I will repeat. First one is finite state. This is the thing, because of input string we cannot check for the context free grammar. A finite state machine is used for the regular expressions. Okay, and push down automata, if we have the context free grammar, okay, because of that we are using the push down automata. Okay, and here Turing machine is more powerful than PDA and FSM. Okay, and in this it is using the tape, and in the tape it must have the head. Okay, and there will be a special symbol, that name is blank symbol, and this is called tape, and this is a infinite. The first one is tape alphabet is sigma. Sigma you already know, we have already seen the previous classes. That is the input symbol A, B, 0, 1, anything, and I will show you the tuples of Turing machine TM in the coming classes. Okay, and the blank symbol is a spatial symbol, and blank does not belongs to sigma. Okay, and third one is blank symbol used for infinite tape. Here if we finish the string, the rest of the tape will fill by the blank. Okay, that is infinite tape. So this is a basic introduction of tuple. Okay. Okay, so once I will show you the difference here. Okay, so this is like, here you can see the following table is a comparison of how the Turing machine differ from finite automata and pushed on automata. The finite automata, it does not use the stack data structure, and this is deterministic. Okay, push down automata is last in first out, it uses the stack last in first out, and it does not it is not a deterministic. Turing machine is infinite tape, it will use the data structure, and it is a deterministic. Okay, so this is less power than push down and Turing machine, and in push down automata is powerful, PDA is powerful than FA. Okay, and here Turing machine is more powerful than FA or FSM, FA and PDA. PDA. So this is about the simple, like why we are using this 3: finite automata, push down automata, and Turing machine, Turing machine in finite tape. Okay. So here, so this is we completed. So now we will move to next, like as I told you here, it is using the tape, but how it is performing the operation in this tape, that I will show you. Then afterwards I will show you the tuples. So the first one is, we can say the configuration. Okay, how to do the configuration to this tape. Okay, like initially configuration is like example A A A, B B B, A A A, and the rest of the things, sorry, I will make a tape, then I will write 1. First one is A A A, B B B, A A A, and afterwards I will write blank blank and so on. 1 2 3 4 5 6 okay. Okay, so this is like my tape, this is my tape, and here where is my header? My header is here, and the first, this is head. Okay, we'll use different color now. Head, head. So now what is the input string? This all are the input string. Okay, what all are this? Input string. And what is this all? This is blank, all blank. Okay, fine. The next one is here operation. I think I need to reduce the size of pen. Fine. Okay, operation on tape. So whatever the tape is there, how will you perform the operation? And what is the condition here? It is telling is 3 3 3. So what grammar it is creating? A power n, B power n, and A power n. This is the condition is performing here. Clear? A power n is different, A power star is different. A power n means the all A, B and A, this all should be equal number of, like 3 3 3. Okay, so this is a grammar. Okay, the first operation in this is, first one, read or scan symbol below the tape, below the tape head. below the tape head. So, here in the starting, or we can say the below the tape head. Next one, update or write symbol below the tape head. So, this is my head and this is a below symbol. Okay. This is my symbol and this is below to head, below the tape head. Okay. Next one is, this both are same, otherwise no need of changing the color. Okay. Here the third one is move the tape, move the tape head one step left. This thing I will write with the red pen, left. Next is move, don't worry, I will explain this with the help of example. Just I am writing the operation, then you will easily understand. With the based on this we will solve. Step is right. Okay. So, these are the 4 operations we need to perform here. Okay. So, this first one, read or scan symbol below the head. So, wherever the head is there, below symbol it will read or scan. Then after that, update write symbol below the tape head, means whatever the symbol is there, you can replace with B, is up to you, or you can replace with any terminal, non-terminal or terminal. So, A is we will go with the terminal only. So, A, in place of A you can write B, update, or if it is empty, if you want to write, you can write symbol below the head. Then after that, move the tape head one step left. So, here the condition like move the tape head one step left. So, when you are at the leftmost, at the last leftmost, if you cannot move to the left, you must stay at the same position. Okay. Or move the tape head one step right. One step is mentioning because you cannot go like 2-3 steps, you cannot take in one operation. You have to take only one operation at a time, either left or right. Any one you need to select and only one step you have to go. Clear? Okay. So, here the down, consider this is in the operation also there is a rules, some of the rules. So, consider this is all rule 1. Okay. And I will take example and I will solve. Example, this is one state and this is another state. Okay. Like this is, okay, sorry. So, this is state for STATE, state. For understanding purpose I am writing this state. This is state and it is going from here to here. Okay. Okay. It is going from this state to this state. How? When A should be replaced with B, sorry, A replaced with B, okay, why I am taking this, normally previously I shown you like A is B, comma A is B, normally we will write like this. In place of this, in the sum of the readers also you can find like this, because of that I am writing this. And here R. What does it mean? When this state the value is A, terminal is A example, okay, that should be replaced with B, comma right, means move to right. First what it is doing? First it is doing the read operation, read or scan the symbol. What is the read and scan the symbol is A. Update or write the symbol below the tape when my head is here, okay, and it is changing to B, and move the tape head one step left, move the tape head on one step right, whatever you want, maybe R or L. Clear? Like here if I draw the tape, this is A and this is a simple example, and this is my head, okay, and consider all are empty, okay, blank, only one is there. So A, first one, read and scan this one, okay, symbol the below tape, update and write. I am updating this, I am cutting this A and I am writing B here, symbol, and move the tape, whatever you want to write, move the tape to right. So in the next step, like in my next, in the next step my answer will be B, and this will be blank, blank, so on, and my head will be here, okay. When I move right, it moved to right, but you will get the question, okay, if it is right, if here example L, move left, what should we need to do? What you need to do means, if you don't have anything here, okay, so you should not go anywhere. If we are at the left end, if we are at the left end of the tape and trying to move left, when you are at the move left end and you are trying to move at the left, move left, then do not move, stay at the left end, okay. Simple logic, if you are at the left end, you cannot move through left. If you want to move left, you should not move, you have to be stay there at the left end, okay. So this is about if we have the L. If you have the right, then you can go to the right, and at the right side, like I am opening this, that means at the right side you cannot be at the right end, because this is infinite, okay. Whenever we are getting the blank symbol, then the operation will stop and will get the result, okay. And what is this A? This is, as I told you here, what is this A? A is reading, reading the symbol, okay. Next, what is this A? A is writing. Whenever like A replacing with B, writing the symbol, okay. And what is this R? R is direction to move from to move left or right or left, okay. So this is simple understanding purpose, the operation on tape, how the operation will go to tape. Like this is, we can consider this is step 1. For understanding purpose I am writing this step 2, okay, like this. So this is about the operation on tape. So this is simple example. I will take another example for just understanding purpose. Like example, one is state, another is state, and this is connected to this, okay, and here I will use different color. A is A, comma R. Example, I have like this, A is A. So this A is reading, example, in my tape A is there and rest of the things are blank, infinite, okay, and my head is here. So head is here, is this A is reading and it is telling to do with the A only. So you no need to do any change here. Whatever the thing is there, A it will be there and it will move to next step, that is your head will move to the next step, okay. So this is a simple thing is there. If you have the same symbol replacing with the same symbol, then no need to change. If you go with the rules, so if it is same also, no problem, this A should be replaced with another A, the result will be same and your head will move to next, okay. So remember every time if anything is replacing with same thing is replacing with same thing, so that should not be change, you can say, or just replace. If you go with the rules, like whatever the rules are here, like if you follow read, write, move, so as per this it will cut this A and add the new A, the same thing will be there, okay, at the same symbol. So this is about the simple introduction, and the next is rule 2, okay, we can say the rule 2. Just I will tell you about the rule 2, and in the next class I will show you the formal definition of Turing machine. Formal definition means how many tuples are there and all the things, okay. So here operation rule 2. So here in the first one, control is with a sort of finite state machine. Control is with a sort of finite state machine, okay. It will control with a sort of finite automatic machine. And the next one is initial state. As usual, what we have seen in the previous videos, like initial state is very important, and the same way it is denoted by this arrow in the starting, and here final state. Here it has the two final states are there. First one is accept, second one is reject. These two things are the first one is accept or reject. Any one of this, any one of this answer, and these both are final state. Final state. That means definitely it will reach the final state even if it is accept or reject. Clear? Okay. And the computational, okay, as per your syllabus, computational language, okay, the computational is computation can either first one halt and accept. There will be a computational like halt, it will stop somewhere and it will accept anything, halt and reject. And the third one and the last one is loop. Loop is nothing but the machine failed to halt. Machine failed to halt. Okay. So this is some of the computation. So for today this is enough. And one more important thing, whatever I am showing you here, you must write in the book, in your book, for understanding purpose. At the time of exam, you no need to watch the video. In place of this, you can write your book. Okay. So the first one is what we have done. Just we will quickly review what we have done today. First we saw the FSM, which is a regular expression grammar, and this is context free grammar for PDA use, and turning machine is using the tape, and it is for the board deterministic, and it will solve the big automata machine problem. Okay. And here the tape has the alphabet sigma, as you know, input symbol, and there will be a terminals. Blank is represented, the new term in the tape is blank. Okay. And blank is does not belongs to sigma, and blank used for infinite tape like here. And here the equation a n b n a n, equal number of a's, equal number of b's, equal number of a's. This kind of problem is difficult, and we saw this kind of problem by doing the pumping lemma problem. Okay. Operation on tape, some of the operation, like we know the tape is there, how we need to perform the operations. Here operation on tape is read scan symbol below the tape head. Wherever the head, read this small, then afterwards the next one is read or update or write the symbol and move the tape to left or right. As I taken the example here, A is one alphabet. Okay, A is here. With the help of tape also I am explaining here A, and it is replacing with B. You can use like this, or you can use this arrow, this or this, anything you can use. A, B, and in the coming classes I am going to use this, only this. So A of B comma R. So what is this A? A is reading the symbol whatever in the tape, and B is writing the symbol in the tape. We are replacing the text, replacing the symbol what it was previously, it is replacing with B, comma R, and the head should move to the right. So, the answer is B and it moved to the right. This is a simple example. If we have the different symbol in the read and write, okay, then you need to change. If you have the both are same, as per the rules you need to change, but the value should be same. Okay, A is same. Okay, and the next operation is with the, it is a sort of FSM only, and it has the initial state and it has final state. How many final states are there? 2 final states. 2 final state. The first one is accept and second one is a reject, and the computation can either halt and accept or halt and reject or machine fail to halt, that means loop. Okay, when it is loop then it cannot be stopped or halt. So, this is about today's class. In the next class we are going to see the formal definition for Turing machine, TM. Okay. Thank you. We will see you in the next class.